Thank you so much, everyone. I don't really know how to follow James. I knew that I wouldn't. And so James has given you an amazing session on some really, really exciting developments in infection control. I'm going to spend 30 minutes talking to you about Dr. Seuss, because I work in pediatrics and this feels like the place that I needed to start. I am going to start by saying quickly how grateful I am to the Healthcare Infection Society for making this award eligible to people like me. So as healthcare scientists, we're on a journey, and this session is all about journeys from my point of view. But a lot of people don't know who we are. And when I started in infection control, I used to joke a lot about being number one in a field of one. I'm really happy to say that I am no longer number one in a field of one. I don't know what number I am, but there's definitely a lot more of us in that field. And so really being open to how different professions contribute to infection control it's such an exciting place to be. And the Healthcare Infection Society have really led the way in being open to how those of us who started in a slightly different way, because I started as a zoologist, can bring something different and still add value. So I just wanted to start with a thank you. If you are just starting your journey in infection control, I just want to say how envious I am of you. I mean, congratulations, it's the first step in the most brilliant journey. If you're on the journey with me, I think we sometimes have to look back and remember how lucky we are, because there will be times where you forget the great places that you have been and the opportunities you have been given. I personally started, as I said, as a zoologist, completely different, and then did an MRes in biophysics, and then discovered, I have to say, I didn't know what a clinical scientist was when I applied for the job, but have since discovered it's the best job in the world, and I'm super fortunate to be able to kind of get into infection control by accident. You had to get a 4th year of training money when you were a trainee when I started, and infection control had money. Just for a year, because they couldn't hire a secretary, so they hired me instead, and I'm glad to say I never looked back. It's an immense opportunity because the field is so big. And I hope to show that kind of even from my point of view, the kinds of random stuff that I've managed to do and the way that my brain has been able to lead me down different rabbit holes has been a massive opportunity. But it's an opportunity that can really make a difference. So I am not a patient person. I think my colleagues will probably stand by that. I was never going to do the kind of science where you spend a decade looking at one pathway and then do something about it. I'm just not that kind of girl. I want to be able to make a difference now. I want to be able to speak to patients and talk about what we're doing. And infection control really enables you to do that and to become the master of your own destiny and to follow your interests. And I started, like many of my scientific colleagues do, with a paper on PCR. And I got my first publication out, and it was as a trainee, and I kind of thought that's where everything would stop, right? I ticked the research box, I got a paper, and then I was just going to go and, I don't know, focus on bench-based work. And then, as I said, an opportunity came up to join the infection control team. And you just have to go with the things that can happen to you. And you have to embrace the fact that you don't know where it's going to go. My first week, I was given the bleep. Everyone else went to a one-day meeting, and I just tried not to kill anybody for the day. I mean, that was genuinely my goal. I had a great infection control doctor who was there as a safety net, but they were like, just do it. You do by learning. And that learning is terrifying, but it will take you to places you hadn't envisaged. And so I started to think that there was a space for research in infection control, and there was a space for science in infection control. So if you remember that I was training, I started in 2004, and at that point we were still very much kind of doing a lot of hand hygiene audits. That was a lot of the day-to-day. You did some outbreak management, but it was a lot of hand hygiene audits. My infection control lead nurse was an amazing woman called Sue McQueen, but she didn't understand PCR. And she didn't understand a CT value, and to be honest, got quite grouchy when they got handed across the desk to her, because the higher the number didn't mean there was more of it. And so it was a new world. We were still manually extracting all of the samples that came in because we only did about 25 a day, and the rest were tissue culture. And so there was a lot of trying to find your space. Because I'm not a nurse, and I'm not a doctor, I haven't got all of that ward-based knowledge. What I do have is quite a lot of knowledge of how to set things up in order to design experiments that answer questions. And that's what we began to see was needed within our world of infection control. And the environment was a really obvious target for us. Partly because at that time I was still quite terrified of going and speaking to a patient, because you don't get trained as a healthcare scientist in how to do that. And I had been screamed at a lot of times by randomly going down because I only got to deliver bad news. And partly because it felt like that comfort zone where science was still really heavily integrated into what was being undertaken. So as I said, I did an MRes in the physics of biological interactions at surfaces, so things like decontaminations, things like stochastic chemistry, I at least had some level of comfort with. And so that's where we started. But at its core, the reason that we went here was my patients are kids. So they're learning to walk in those spaces. They are putting everything that touches the floor into their mouths. That is just what they do. They're going to be spending up to 2 years in those rooms. And so we felt the environment mattered, and we did some really basic work in terms of things just like looking at door handles. And we did some work at the National Neurological Hospital, and they had this amazing layout. They just redesigned their surgical ITU. And they had done it in a way that looked great on paper. So on paper, there were 2 doors, one to the left and one to the right. And everyone thought you would use the door to the left because it was closer to the stairway. In the end, everyone uses the door to the right because it's closer to where the patients are. Sadly, the door to the right was also the door that led to the sluice that everyone carried all the clinical waste out of. And they'd put a lovely dispenser by the door that every single visitor used. Every single person came through who didn't work in that trust. And it was great. They had amazing compliance with using the moisturizing cream on the way in. So every visitor thought they were protecting the person they were going to visit, because the person who put the dispenser there assumed people would know the difference between black and blue and red color coding because they weren't labeled. And so it just gave me an insight to the fact that we have to look at these spaces differently. And the fact that children are not just small adults. So having gone out to other trusts and realized that my patients don't behave the way that your patients do. And so everybody, I remember being constantly told that flaws do not matter in infection control. Flaws don't matter at all. I tell you what, if your patient's spending 3 hours a day learning to walk and crawling around on it, flaws matter. If your patient throws something onto the floor every 15 minutes because they think it's really funny to see people run and grab it, flaws matter. And so these statements that we make in infection control are not true in all settings. And so suddenly I had an idea of the fact that I wanted to take this somewhere. And so I ended up, this is obviously the obligatory thesis picture, just so that me and James feel like you can all enjoy the fact that we spent quite a lot of time on this, even though it's now a book stop. I do feel like if anyone ever tries to like break into my office and steal anything, I have a weapon to hand and everything will be fine. So I did a PhD on the role of the environment in transmission of healthcare-associated infection to try to pull on some of these strings a little bit more. And I finally got my first author paper out. I was so excited. I thought I was there. Really wasn't there, but I thought I was there, on how sink placement, of all things, really impacts hand hygiene. And so we'd all moved to having one sink per bed space, right? You think this is great. We have 3-bedded bays. Everyone steps out of the bays at either end into the central bed space in order to undertake hand hygiene because it's the most visible, despite the fact they all have a sink per bed space. And worse than that, if you put in sinks that then don't get used, you have microbial flora that then has loads of time to build up in between. So when you do go and use it, and 60% of the back of my sinks are colonized with fecal flora because most of my patients are in nappies, you put your clipboard on the back of the sink and you take all that fecal flora with you after you've kindly washed your hands into the next bed space. And it kind of made me realize that research is definitely a journey and not a destination. Because these things aren't straightforward. And you come to sessions like this and you think that you're being left behind because everyone is doing such amazing work. And we don't necessarily talk about the challenges linked to that amazing work enough and sharing how we deal with some of those challenges or just acknowledge that it's okay that they're there. So I had decided environmental IPC was the thing, right? It's super important. It was blatantly obvious to me. And then I tried to submit papers linked to it. And every reviewer's comment came back saying the environment is not important. It took me months to get anything out. I had to send it to multiple journals. You had to pick your country really carefully. You couldn't just go with where people would find this useful in terms of publication, because I just kept getting told that the environment is not important. And to that, I would like to reply that the BBC headlines over the weekend about Glasgow and waterborne infection shows that it is. But this was some time ago, and we've come a long way since then. But sometimes you just know that you have to stick to your guns and acknowledge that sometimes you have to bring people with you in order to have those conversations. This is the paper that inspired me to carry on. It's an old paper. I talk about it a lot as my favorite paper of all time. It's about the release of cauliflower mosaic virus DNA into a ward. And do you know, every now and again, you read a paper that makes you think there is so much more that we can do that we're not doing yet, that inspires you to carry on. For me, it was this paper. Tiny study, right? They released bits of cauliflower mosaic virus DNA as a marker into an NICU, and they looked at how far it spread. And it made me really think about how every time we're doing something in infection control, we're basically on the back foot. Because we've got an output and we don't know where it starts. And we make assumptions about where it starts. We make assumptions about what interventions will work. We guess, best guess, about how to do it better. But we don't have a way of sticking something down and actually looking at what those transmission routes really are in order to validate the decision-making process that we have. And I have a lovely PhD student at the moment called Sam, and a previous one called Stacey, who have done so much work so that, just to bring things a bit of a full circle for me, we have managed to recreate and hopefully slightly improve this paper, because it was when you couldn't make synthetic DNA in the same way that we do now, in order to show and give us a tool where we can in real time look at how tracking works in infection. And we've just spent the summer redoing this on 4 different types of wards. So a hematology oncology day unit, a surgical cardiac day unit, a cardiac intensive care, and a hemonc long-term cubicalized ward. And I can tell you that most of the assumptions we make are wrong. I can tell you now that, like, I have a one-size-fits-all kind of toolbox of interventions, right? Because you assume that wards work the same, and they don't. Those pathways are completely different based on the patient that's in them, the way those families behave, and what kind of acuity the staff have got. So our hemonc day unit, God bless them, they do everything they can. But those kids see each other 3 times a week and they become friends. And then they play hide and seek in isolation rooms that have not yet been cleaned. You know, there are spaces like that that are really challenging versus your surgical day unit where someone comes in, gets sedated, they go off to theatre, the parents go for coffee, and then they either come back, get discharged once they've woken up, or they go into intensive care. Both of them have routes of transmission, but they're very different from one another. And the ones that we'd asked the wards about ahead of time, about where they thought their risks were not where we found the risk. But on several of those units, you will find that if you put 3 markers, one on a staff object, one on a patient-only object, and one on a general ward object, will spread to 40% of the other sites within that space within 8 hours. So if you get something there, knowing how to shut it down quickly, knowing how to use your different cleaning agents or other things, thinking about, are you getting everyone to moisturize their hands really well when they come into the unit versus actually dropping their loads is really important. And you will get there. I don't know where there is yet, but you will get there. You will just do amazing things. I was so excited when I got my last author paper, and I was even more excited that it was on environmental sampling. Because I publish on whole genome sequencing. I've published on the sexy stuff. The environment isn't sexy. People are never going to get excited when I talk about log kills versus when I talk about SNPs in the same way, right? They just aren't, but I fundamentally believe that this stuff matters. And the fact that my first senior author paper was on how we do it better and how we have better conversations was just worth the world to me. And also that, again, the Healthcare Infection Society have really supported all of these random journeys that I've gone on, including funding a PhD student to undertake work looking at the environment and how we use it to better inform infection control decision-making, but also funding it to do things like create a play called Sock the Puppet for children to talk about organisms, stuff that you'd never thought you'd do when you started out on this journey. I'm going to take a very short moment to talk about the very best virus, and I will brook no argument. I know people think it's all about SARS-CoV-2 these days. It's not. It's always been about adeno. The fact that it was really, really popular in the 80s and no one's cared since then, apart from a small blip a few years ago about adenohepatitis, it's just because you just don't want to be retro like me, but adeno is the best virus. It's something that I've been really interested in because it will survive in your environment for up to 3 months. It's something that in pediatric hematology oncology units can have a mortality rate of 50 to 80% if it is acquired. And yet it's something we don't look at. So we don't look at it because it's challenging. We don't look at it because it can reactivate during a BMT, and so it's really hard to know whether the fact that you've got a new primary infection, because a lot of these kids are at the right age to get a primary infection, or whether it's reactivation and what we do about it. But one of the things that I'm proudest in my career about, and this probably sounds really mediocre to many of you, is that we now have a policy where we screen a room post-discharge. And if that room is not adenovirus-free, we do not put a patient in there. Because one year we had 3 deaths, and now we don't. And that makes a difference to the people that are could be exposed to this virus. Now, that doesn't mean we're perfect. We constantly find new acquisitions because, as I said, they're kids and their parents will speak to each other, and occasionally their cousin with the same condition is next door, right? You have network roots, which James so beautifully showed. But there are fundamentally quite simple things we can do if you're prepared to put in the resource in order to make people safer. I mean, Klebsiella, again, is the best bacteria. It is, it's just super clever. And so I've been really lucky to do quite a lot of work, again, because Klebsiella, before it was famous for sinks, for which I'm now actually secretly quite grateful because people don't look at me quite askew when I talk about the fact that we used to do environmental sampling for Klebsiella. It's always been a big deal for us because we had things like one of the first NDMs from that Lancet paper at Gosh, and because we knew we had environmental transmission issues because, as I said, 60% of the back of my sinks have fecal flora on them because nappies, right? And so even before you get to true sink colonization, it is an issue for us. And yet, when I started out, there was such little understanding of how you type, how you look at core versus accessory genome, how you look at plasmids. One of the other things that I'm really proud of, although I made a rod from my own back, is we now look at plasmid-mediated outbreaks for our CPEs, not organism-mediated outbreaks, because the mechanism is so important. That's a really exciting change for us in terms of, I think it's where we need to go. However, technically, it's a really challenging change for us because how do we make sure that we are looking for mechanism, which is not what IPC has been traditionally set out to do. And every now and again, you'll set yourself a challenge, and it won't necessarily pay off. And I talked about how valuable those lessons are. And I have failed a lot. But actually, it's in those failures, I think I have learnt more than in my successes, right? In trying to put papers through where people were like, this is just not important, or this area doesn't matter, this won't make an impact on patient change, or the brilliant one that I got from the NIHR, which, God bless them, they now have funded me multiple times and I forgive them, was that scientists can't make an impact on patient care. So we don't fund lab science because it can't change infection control. That taught me, and it taught me to work on my pitch, and it taught me how to have conversations differently. And I think that's so important if you're going to be working in this area, because things aren't clear-cut. We can't run mass clinical trials. We can't get the kind of data that often clinicians and other people want from us, because I can't just turn around and say, oh, well, don't clean in this half of the hospital for this week. And so we have to become better at answering those questions, and sometimes failure enables us to do that. It also sometimes enables us to think about how we're going to come back. So I was told that as a healthcare scientist, I would never make professor. I was told that as a healthcare scientist, I would never get an academic grant of over £1 million in my original research institution, because that was the realm of the medics and there wasn't room for someone like me. And so what I did was I sat down with one of my great scientific colleagues, who's now also a professor, Lena Sirik, and we were like, how do we even this playing field? Where are the gaps for people like us? And we looked around and we were like, you know what, the Engineering and Physical Research Council would love a bit of us. And we put in one grant for £998,000 and we got it on the first time. Because sometimes you have to know that the barriers are there and you have to find a way around them. And then we came back with our just shy of £1 million grant and put in for research funding at those other places. And you know what? Surprise, surprise, they no longer cared that I wasn't a medic. because actually money talks and CVs talk, and sometimes you have to be strategic enough to know the way to change the landscape in which you're in. And we got a whole bunch of papers out of it. And we created networks that enabled us to think differently, and we are stronger because of it. And so sometimes those no's turn into the strongest yeses. And occasionally, you'll end up in territory that you know nothing about. I'm going to make a confession. Please don't think less of me. A few years ago, my professor came to me and was like, would you like to go to Bali 6 times a year? And I went, yes, that sounds amazing. Let's do that. And then I was on a phone call to the WHO in Geneva, and they brought up the map of where this massive clinical trial was going to be. And it was a landlocked country. There was no beach. And suddenly, it gradually occurred to me that the name on the map was Mali, not Bali. And so I had committed to running a clinical trial for every child born in Mali for the next 5 years, not Bali. Don't know if you know much about Mali, but it's got a lot of ISIS. And yeah, it's very red on the Home Office map. And trying to explain that one to your husband when you come home is not an easy one. But that said, we have got a plan that is looking at reducing infant mortality in Mali by 20%. And that's the kind of work that I never thought that someone like me would get involved with. But it enables change on a whole new level. And the other thing that changes on a whole new level is thinking about how you talk to people. So I work in pediatrics. They don't care about your research paper. They do not care about my title. They do not care about any of that. However, if I speak to them and I bring a sock puppet into them to talk to them about infection, that they care about. I'm traumatized by the gosh clowns, by the way. I do not want to take gosh clowns into anywhere. And so it made me really think about how do we have conversations? Because it is no longer about you and me being an expert in the room. It is about how we co-create that healthcare environment with our patients, with their families, with the communities out there. And that works by telling stories. That doesn't work by telling facts. And so in Infection Prevention in Practice, we have a paper coming out next week for Antimicrobial Awareness Day about how you have conversations with people about things like AMR. That doesn't mean that you just sit there quoting the fact that more people are going to die of AMR than cancer by 2050, because I can tell you, that's a cold ice bucket of water on any conversation, because people are scared by stuff like that. It disempowers, whereas actually to make a difference, we need to empower people. And you will move mountains. You will do things you would not have believed possible, including apparently potentially going to a country that may behead me if I go to the wrong part of it. But we will make great change on the way there. And so I just want to really encourage anybody who is beginning this journey, is partway through this journey, feels like they're on top of it, to continue to ask the questions and to open their minds to those new possibilities. And just a thank you to everyone, because this stuff takes a village, right? It takes so many people to have faith in you, to keep you going, to inspire you, to collaborate with you, to make that difference. And a massive thank you to FIS for giving me this award. I really appreciate it.